Hello everyone, this is Adhish. I'm a grade 10 student from Mumbai. So today's problem is, can you eat it? The difficulty level of this problem is cakewalk because this was the first problem in this contest. And you only need to know very basic mathematics like divisibility and how you can check whether one number is divisible by another number or not. And what is the quotient when you divide one number by another number. So in this problem, we are basically given a candy of length n and we need to eat this candy by doing some operations. Now each eat operation will take place when we eat a candy of exactly k units. So for example, if we take one bite, the length of the candy will change from n to n minus k, and it will keep repeating like that from n minus t to n minus 2k and so on. However, we always need to ensure that the candy's length is positive. Obviously, we can't eat negative candy. And like if the length is less than k, so for example, if n minus k becomes less than k, then we can't eat again, we can't do another k operation because that would make the candy's length negative. And we need to print -1 if it's not possible to eat the candy, otherwise we need to print the minimum number of bites the candy. So for each test case we are given n and k and we need to print the minimum number of bites. So for example, let's say that n is 3 and k is 2. So this means that initially we start from 3. So that's the initial length of the candy. Then we have to take a bite of length 2, which will reduce the candy to 1. And we can't take a bite again because 1 minus 2 will give -1, which is less than 0. So it's actually not going to be possible. So it's not going to be possible actually. So we'll print -1, and this is the second example. For the first example, so like we just print -1 in the second example. For the first example, let's say n is 3 and k is 1. Then in this case, we go from 3 to 2, 2 to 1, and 1 to 0. So note that the number of arrows, so we need to count the number of arrows, and the number of such arrows is 3, and that's why the answer would be 3. So since there are 3 arrows, basically we are doing 3 operations, the answer would be 3. And if we consider another example when we have n is 0 and k is 3, so in this case we don't need to do anything because we already finished eating the candy. The candy is of length 0, so that's why we print 0. And now this is basically what the problem is asking us to do. So let's make one observation, and that is the only key observation required to solve this problem. So the only key idea which you need to solve this problem is that you need to be able to think backwards. So we know that we end up with a candy of length 0 in the end, and if we don't end up with a candy of length 0, we'll print -1 because in the end we just want to finish the candy. So we know that if the answer exists, it would end with 0, and that means we came from a position k, right? Because only from a position k can we come to position 0, because only if we eat all the k pieces inside a candy of length k we can come to 0. And we could have come to a candy of length k only if we came from a candy of length 2k. And similarly, we could have come from a candy of length 2k only from a candy of length 3k. So you're getting the pattern that in general, we can only come from a candy of length x into k to a candy of length x minus 1 into k all the way up till all the way up till a candy of length 3k, and then a candy of length 2k, and then a candy of length k, and then a candy of length 0. So in this way, we know that we always have to ensure that we are coming from a candy which is a multiple of k, which is x into k. So you should pause the video and think about why this is true. So the reason why I'm just repeating it again to emphasize the idea is that the reason why this is true is because we know that the candy's length is 0 in the end, and we know that before that we ate exactly k units. That's why before that the answer would be k, like the number of candies would be k. So we know that since we ended with 0 units length in the end, this means that we came from a candy of length k because we always eat exactly k units. So since we ate exactly k units, we have a candy of length k before. And before that, we had a length of 2k because 2k minus k will give us k. And before that, we had a candy of length 3k because 3k minus k will give us 2k. And so on. Each time we kept reducing the length by k. And that's why we always need to come in this manner. We always need to come from a number xk to go x minus 1 into k. And then x minus 2 into k all the way up till 3k, 2k, k and 0. So therefore, we can conclude that if the length of the candy is x into k, so um, we conclude that n should be equal to x into k, because we know that the only length of the candy should be some number, some multiple of k, and that's x into k. So let's say n is x into k. So therefore, we get the value of x is equal to n by k, and basically n should be divisible by k. So we need to ensure that n percentage k is 0. So if n percentage k is 0, then we know that the value of x is n by k. Now the second observation is the number of steps. So we know that the length of the candy should be divisible by k, and now let's find the number of steps. So the number of steps required would be, so again you can see a pattern. We had basically one arrow sign when x is 1. So when x is 1, there's one arrow sign. When x is 2, there are two arrow signs. That means we require two operations. When x is 3, there are three arrow signs. And in general, when x is like any number x, then in that case, we have a total of x arrow signs. And that's why the number of operations is just x. So we'll just print x, which is n by k. That's all that we need to do. So the final code or the final pseudocode will look like, if n percentage k is equal to 0, we print n divided by k because that's the value of x and that's the number of operations. Otherwise, we'll print -1 because we know that it's not possible to get the to get a candy of length 0. However, there's a catch, and this is where like a lot of people could be making errors, especially if you're using Python. So if you're using Python, a possible error which you'll get is to do what I just said. If you do what I just said, and for each test case, so you'll take in t, for each test case you'll take in n and k. If n percentage k is 0, you'll print n by k, otherwise you'll print -1 and you'll decrease t by 1. However, this does not work. The reason being, if you run this on the sample cases itself, it won't work. In the sample cases itself, it won't give you 3, -1 and 0. It will give you 3.0, -1 and 0.0. The reason being, so the reason why it will happen is because n by k will become a float data type and that won't work. We need an int data type. So to solve that issue, we take the exact same code. So to solve that issue, we take the exact same code and we just change the 6th line to be int n by k. So in this way, you'll realize that we're always printing an integer and not a float. So we're always printing 3 instead of 3.0. And that's why this code will get accepted and this code will give a wrong answer. That's the Python solution, and the C++ solution doesn't matter because we explicitly give int. So that's the advantage of C++. As you can see, we explicitly give int and we print n by k, so that's also an int. And otherwise we print -1, so there's no such issue in C++. And that's basically the full solution. If you had any doubts, do leave them in the comments down below. And if you like this video, don't forget to give it a thumbs up. Thank you.